Welcome to the Albuquerque Journal's Tech Outlook podcast. CNM is truly one college with infinite possibilities in tech and data sciences. CNM offers programs where everyone can learn about software, apps, or how to build websites. You can also choose from AI programs and machine learning, the Internet of Things, and so much more. CNM, one college, infinite possibilities, and the proud sponsor of the Tech Outlook podcasts.
Hi, welcome back to Tech Outlook. I'm Ryan Botel with the Albuquerque Journal, and with us here today is Jake Douglas. He's a technical business development specialist at Sandia National Laboratories. And the topic that we're here to discuss today is the Quantum New Mexico Institute, which was created in January. It's a partnership between Sandia and the University of New Mexico. Jake, to start off, can you tell us a little bit about yourself and what does a business development specialist at Sandia do?
Yeah, absolutely. Thanks for having me today. Business development specialists at Sandia help bridge the gap between our technical goals and then our long-term forward-looking strategic plans, partnerships, workforce development, things of that nature. A little background on myself. I was born and raised in Roswell, New Mexico. I went to school at New Mexico Tech, got my degree in chemistry, went back to Highlands and got my MBA, and then jumped in at Sandia about 6 years ago now, where I've been working with a quantum program for pretty much that entire time.
And can you explain to our audience what quantum technology is?
Yeah, so essentially, quantum technologies are taking advantage of quantum physics to do new types of things in computation, sensing, and communications. So it'll give us a whole new tool set to do modeling, or quantum sensing will give us some capabilities in GPS-denied navigation, things like that.
And can you tell us a little bit about the history of this institute?
Yeah, so about 2 years ago, Sandia and UNM started thinking about ways where we could really capitalize on the deep history that we have in quantum. In 2018, the National Quantum Initiative was passed to really create an all-of-government approach for the U.S. to advance quantum technologies because it has really interesting and potentially transformative national and economic security impacts. And so when we started talking, we wanted to really stand up New Mexico as a key player across the globe because we were foundational in the field. UNM started doing this 30 years ago. Sandia and Los Alamos National Labs got into it 20 years ago. And we've made a lot of the breakthroughs to get to the point today where we're starting to see some of the impacts of the technologies coming to market.
Because we were talking earlier, quantum technology as quantum science has been around for decades. But just in recent years, there's been some emerging breakthroughs, essentially.
Yeah, so it's been around for about 100 years when people started playing around with quantum physics and how weird they are. And like you said, it's been the past 5 to 10 years where real breakthroughs have been coming through in engineering and our understanding of how these systems work. So we're starting to see a lot of startup companies come out. There are a few public ones now like Quantinuum and IonQ. And they're starting to do interesting things with them. It's still about 10 years out before we think quantum computers are going to be able to do really great, impactful things. But we're starting to play with it now and really understand the potential transformative nature of it.
And you were mentioning a 2018 law. In recent years, there's a lot of federal money being pumped in to advancing quantum technology.
Yeah, so in 2018, the federal government passed the National Quantum Initiative, which helped create that all-of-government approach to advancing these technologies. So places like the Department of Energy, the National Science Foundation, and NIST, they all got a large amount of appropriated funds, so over $1 billion, to go through and try to advance these technologies for the good of the country. Sandia National Labs helps co-lead one of the DOE flagship centers, the Quantum Systems Accelerator. UNM is a key partner in that. We have some other regional partners like Boulder, LANL's engaged. So New Mexico in our region is playing pretty large roles in that the overall context of the National Quantum Initiative.
And from a national security perspective, why does the country want to invest in quantum technology and be a leader, a global leader in it?
Yeah, so overall, it's just going to give us these new cool tools to do things that matter across the national security complex. The most interesting one, though, is around cryptography. So with a sufficiently large and sophisticated quantum computer, we think that we'll be able to go and break a lot of different methods of cryptography, which could be very worrying if the information that we're connecting protecting through cryptographic methods is then compromised. So keeping our national security secrets safe, keeping our bank transactions safe, things like that.
And that's essentially what cryptography is?
Yeah, it's the way that we protect our data electronically.
And better quantum technology would essentially create more security for those sensitive transactions and data.
Yeah, and across the board. So our healthcare system, finance, everything, we use cryptography to protect that data now. And that's how we can keep our information safe. So that's a big worry.
Okay. And this new institute, it's my understanding, so right now there isn't a physical building that houses this institute. It's more of just a collaboration between researchers at the labs and the university. Is that correct?
Yeah. So to kick things off, the building is our eventual goal. And we actually just submitted a proposal to the Economic Development Agency with some partners in Colorado to try to get that building funded. But the current state of it right now is each institution has made that commitment to stand up this really dedicated and different partnership. So, for UNM, they stood up this new university-wide center that's going to pull from different disciplines, be it physics or computer science, engineering. Hopefully we can get the business Anderson engaged to try to help create that that kind of like full spectrum approach to advancing quantum tech. With Sandia, it's going to provide better research opportunities. We want to really build up that workforce and share our expertise with others across New Mexico.
Because at Sandia, is there a quantum department? How is the quantum field organized?
Yeah, so quantum is super multidisciplinary, which makes it kind of challenging. So it draws from physics, from electrical engineering, from math, all these places. And at Sandia, we have a pretty large quantum program. It's the largest of the Department of Energy National Labs. And it's across both kind of the theory and applied side, so experimentalists and theorists. Sandia is one of the only places in the world where we can make working quantum devices, so quantum computing processors, quantum sensors, things like that, where other places can only do one or two. We have multiple that we can actually do. So we're scattered across the labs. We have a world-leading quantum performance lab that can go out and work with industry to tell them if their computers are working the way that they think they should be, or assessing how good they're actually doing, because they're pretty complicated and hard to understand. And we maintain a lot of really interesting capabilities to help enable the broader ecosystem.
What type of so the people who work on the quantum program at Sandia, they have a wide variety of academic backgrounds and multiple math disciplines?
Currently, most are PhD holders. Physics, computer science, electrical engineering. But we're moving into kind of an era where we're pulling in a lot of other people in those adjacent fields. So they got their PhD in electrical engineering, and they didn't learn specifically about quantum, but the skill sets are super similar. So they can come in, get a little bit of background information, and then make really great contributions. Additionally, we're exploring ways now to really start building out the rest of the field as it's growing, to start building out technician jobs and start working with undergrads and things of that nature. And that's something we're hoping the Institute can help us achieve.
Okay. How would you compare or just rate how Albuquerque, where it stands in the world of quantum technology? Are we already at the forefront of this field, or do we need to catch up?
Yeah, no. So this is a field where we're truly world leaders. And we're kind of at that inflection point where we need to organize if we want to continue being leaders. And that's one of the driving forces behind setting up this institute. And like I said, we put in a proposal with a group in Colorado called Elevate Quantum, and it's to really spur the economic development piece, because New Mexico and Albuquerque have incredibly strong academic and national lab partners. I haven't talked about AFRL yet, but they have a lot in sensing and communications, and they're going to develop some great capabilities. But we're missing industry. And so through this proposal and through Q&M, we're really hoping we can start drawing industry here, because they want to work with us. They want to work with our quantum performance lab. They want to take advantage of our fabrication facilities, which are world leading, things like that. And through a coordinated partnership like this, we really think we can get there and have the impact for Albuquerque and New Mexico in a way that we haven't seen before.
Okay, so that's interesting. So New Mexico is a leader in quantum technology at its universities and within the national labs, but we're not necessarily capitalizing on an economic development side just yet.
Not yet, but there's a lot of pieces moving right now to help us get there. So we actually just stood up a group with the New Mexico Tech Council to try to start engaging the broader tech community and others who are interested in just learning about what quantum is in a once-a-month type venue where we can talk about, hey, what are those workforce needs? Where do we see the economic impact? How can we actually plug in and start bringing some of that to the state? And then, the Elevate Quantum proposal, it's an industry-led proposal, and we're strong partners with that. And we have a lot of support from the community and the state and others to try to do that. So we're getting the pieces in place now to really capitalize. And, the launching of this institute is kind of a keystone of that.
Okay, great. And can you give us an example of a business that has harnessed quantum technology and used it to find a solution for a problem?
Yeah, so that's kind of one of the tricky things, right? It's an emerging technology, and we're still trying to figure out exactly how it works. And so quantum computers haven't proven that they're going to be useful yet. There's a lot of theory. There's a lot of potential applications that people are very excited about, and that's why we are seeing a ton of investment, the all-of-government approach, things like that. But we have seen some interesting hybrid approaches where we use both quantum computing and classical computing and things like finance, where we can go through and improve fraud detection by using algorithms from kind of both worlds. And we're really interested in what quantum might be able to do to kind of simulate physical systems, and that will play a big role in like drug discovery, right? Right now we have some brute force kind of methods, and it takes a lot of computing and a lot of guessing. In quantum, since it's that type of systems itself, should give us really cool new capabilities for drug discovery and design, things like that.
Okay. And I've heard of this concept before in this test that's coming up where a quantum computer versus a classical computer, which one can solve problems quicker. Can you just explain what that race is?
Yeah, so I think it was 2019. I might be off a year or two when Google put out a quantum supremacy paper where they came up with a type of problem that is just incredibly hard, and it would take billions of years for a classical computer to run. But they showed with a quantum computer they could do it in minutes, right? And so that's huge discrepancies. But it's kind of a toy problem, right? It's something that was contrived to show, hey, there's some advantage here. But quantum computers are more probabilistic, right? So it's going through and it's going to allow us to solve the problems in just new types of ways without the deterministic kind of outcomes that we see with classical computing. So like if we were to try to solve a maze, right, a classical computer can take one route at a time, and it will say, yes, maze completed, maze not completed. And it'll go through iterations until it can get through the whole thing, right? And that's going to take a lot of time as it tries route 1, route 2, route 3, route 4. But a quantum computer, just based on the principles behind it, it can go through the maze and try every route at once. And so it can go through and solve that maze much quicker, just as kind of an example. Okay.
Well, and I think that is a very good example for then explaining how that could be applied to drug discovery, where you were kind of talking about it in a lab. A drug discovery might take a scientist meticulously going through data point after data point, whereas quantum computing could kind of cut that process in half. Is that a okay understanding of it?
And exponentially, so not even in half. But the challenge is going to be creating the algorithms to actually do that. And so that's what a lot of our smartest researchers are working on now. And I just saw an article come out from Google where they put out a $5 million challenge prize for someone to bring them a useful algorithm that can actually solve a real problem today. Mm-hmm. So we still have some work to do.
Okay. And if there's an emerging quantum economic ecosystem in Albuquerque, you're going to need some very smart, well-trained people to fill those job positions, right?
Yeah, absolutely. And that's kind of the model we have now, right? A lot of people going and getting their PhDs, master's programs. But the most interesting opportunity that I see kind of from my point of view is as the systems continue to develop and grow and get commercialized, we're going to need people thinking about the really hard next steps, but we're also going to need the people who can go through and actually maintain the systems and run the systems. And for those, we think there's a lot of great opportunities for high value jobs for technicians. We're working with Central New Mexico Community College and some community colleges in Colorado to actually stand up a hands-on learning lab where folks can come and get trained on optics and lasers or on vacuum systems or things like that, where they can go and work on these awesome systems who, can these advanced technology things, but not have to go to school for 10 years.
Okay.
And so we're super excited about that. And that's a huge area of growth that we're seeing within the field overall.
Okay. Who's working to try to introduce young students to quantum science and maybe just direct them down that career path?
Yeah, so Sandia actually has some foundational programs here. So we have a high school summer camp that we call Q Camp, so Quantum Computing, Math, and Physics. And it's an introduction for both high school teachers and students to just general quantum concepts. This year, we're holding a 4-week student camp that'll be hosted with UNM, NMSU, LANL, a nonprofit called Computer Science Alliance, and others to reach communities across New Mexico, so Albuquerque, Santa Fe, and Gallup, and just introduce the students there. We're also holding a teacher camp. It's going to be 3 days this year where we bring teachers in. We have some modules that can plug into existing standards and just start demystifying quantum a little bit. And there are some other programs that are out there, but locally, that's what we have. And we're working really closely with UNM. They have a Q-Reach undergraduate research program that can bring students in across the state and things like that.
Jake, you mentioned Q Camp, which was for high school students to introduce them to quantum principles. Can you give us an example of a student who went through that and maybe it affected their career or their field of study?
Yeah, absolutely. So we initially kind of dipped our toes into trying to introduce quantum a few years ago through a program with ORISE. And it was a 2-week program. We had to create materials from kind of scratch and worked with a contact at Sandia, Megan Ivory, who's our technical lead, and came up with some really awesome materials. And one of our students from that, she actually got really inspired after going and learning from these, engineers and scientists, and she decided that she wanted to study quantum communications. So she's from El Paso. She's first generation. No one else in her family had gone to college, and she reached out to the team, and they got together so she could do a research project that she took to science fairs. She won international science fairs with what she was doing. She was able to go work with NASA. Since then, she's applied to a ton of different Ivy League and top tier schools, and she got into every one of them.
Wow.
And so, just from the introduction, obviously she already liked science, but quantum really captured her. She was able to connect with our mentors, and her trajectory is to go make really awesome contributions to the field.
A first generation American takes a boot camp, is working for NASA, and is now in Ivy League school of her choice.
Yeah. And, that's really what we're trying to do with Q Camp. We're, no prereqs to come learn about it, right? You don't have to be top of your class. We want to work with the communities from across the state, from Roswell, from Gallup, from others, just so they can get a flavor for the field and see if it's something that interests them. And we actually are able to pay our students to come rather than having them pay, so they don't have to choose between going to work or learning about science.
Okay, so there are these specific efforts to actually, you're calling it quantum, but you're reaching out to undergrad and high school students and kind of, you said demystifying, but making quantum principles sound not so scary to somebody who doesn't have that degree yet.
Yeah, and most people make their decision on what they want to do in their life in high school or even middle school, right? And so if we want people coming into quantum, which no one really understands well, right, and it's hard to communicate, we need to introduce it a lot earlier. And there are a lot of really applicable ways that people can get engaged. It's just the challenge that we're seeing is being able to educate people and get the word out. And so things like this are perfect for helping start that journey.
And let's look into the future a little bit. If this institute is successful and the quantum principles, the quantum research and I guess know-how that exists in New Mexico is applied to its economy, what does that look like? What is a quantum company in Albuquerque look like in the future?
Yeah, so lots of different options here, but in 10 years, we're hoping that we can draw both kind of the full stack providers, the quantum computing companies like Quantinuum. They're a pure play quantum startup. They have about 500 employees, and we want to bring them here to establish a presence in New Mexico and really grow out that quantum computing capability. Could also be working with the enabling tech community. So you need a lot of lasers to set up quantum systems. So how can we work with them, or the folks who are setting up cooling? Cryogenic cooling systems, things like that. And we have great partnerships with people kind of, again, across the world in these areas, but bringing them here to establish jobs and establish the community that's going to have access to these huge national labs and, customer sets, but also start building out into, the broader economy there.
Because you had mentioned earlier, and I wanted to go back and ask about it, that a quantum economy isn't just PhDs who have studied it for 10 years. There's also a possibility for a quantum technician. What would that look like?
Yeah, so less than half the jobs currently in the ecosystem require a PhD. So we're already seeing that shift, and that's why we're trying to stand up these community college programs to start working with those technicians. And, a lot of it's going to be on maintaining systems or really understanding some of the enabling tech pieces. So like I said, the lasers, the vacuum systems, that kind of stuff, and making sure that things are up and running. And there's going to be opportunities for these systems. We're going to need people who can weld and solder, and there's going to be a lot as, if we can build up a local ecosystem, a lot of the construction pieces that are going to have to come in. And we're trying to really drive into the numbers of what that looks like. And through the Elevate Quantum team, we think in 10 years we'll need 15,000 people, right, to help support the sector here in our region. And right now we have nowhere near that. So creating programs that will have the outputs we need in that time frame is kind of top of mind.
Okay. And also, it seems to me that it makes sense that Sandia and UNM would be the partnership in Albuquerque to try to drive this development.
Yeah, 100%. I definitely don't want to leave out folks like Central New Mexico Community College. LANL is going to be a huge partner, as will AFRL. And we're starting off with UNM and Sandia because we have had such a long, rich history of working together, and we just want to do something bigger and better now, and really serve the nation in kind of new ways. And we have the ecosystem to do that here.
Well, Jake, thanks a lot for coming in and taking the time to try to explain this complicated technology to us. We do appreciate your time.
Yeah, absolutely.
All right. Thank you very much.